Transact-SQL is the main language used to manage and manipulate data in Microsoft SQL Server. This lesson lays the foundation for querying data by using T-SQL. The lesson describes the root of this language, terminology, and the mindset that you need to adapt when writing T-SQL code. It then moves on to describe one of the most important concepts that you need to know about the language, that is the logical query processing. Now, before you complete this lesson, we expect you to have some understanding of basic database concepts. You should also have some experience working with SQL Server Management Studio, that is SSMS, and some experience writing T-SQL code. We have given you the database for the lesson and for the exercises that you encounter in this lesson and the subsequent lessons. And the database is called AccuTextDB, and we expect that you have installed it on your computer. Many programming languages don't last long because they don't have solid foundation. T-SQL is different though, because the foundation is based on mathematics. T-SQL has got strong mathematical foundation. And even though you don't have to be a mathematician to understand the concepts, you need to know the fundamental principles of mathematics on which the language is based. And after this lesson, you should be able to perform the following tasks. You should be able to describe the foundation that T-SQL is based on. And you must be able to describe the importance of using T-SQL in a relational way. And you also be able to use the correct terminology when describing T-SQL related elements. As I mentioned earlier to you, unlike many other programming languages, Transact-SQL has got a solid standing and foundation in mathematics. Understanding these concepts will enable you to write solid and better T-SQL codes. This will help you to think in T-SQL terms when you are writing your code, instead of thinking in procedural terms. The next screen I'm going to show you will enable you to appreciate the relationship between Transact-SQL and the standard SQL. As you can see from here, Transact-SQL evolved, or is a dialect of the standard SQL, which also depends on the relational model, which takes its principles from set theory and predicate logic. The SQL language, of which Transact-SQL is a dialect of, is the standard for the International Organization of Standards, that is ISO, and the American National Standard Institute. These two standards are basically the same. Each database vendor implements a certain aspect of the standard of SQL in their database management systems, just like what Microsoft has done. They may include some aspects of the standard SQL, that is, modify some aspects of the language when they think that the standard is lacking some features that they require. They might also decide to leave some aspects of the standard language as a matter of implementation choice. As you learn SQL, if you base your learning on the standard way of writing SQL, your knowledge will be more portable and the code you write will be more portable, because the standard is used by many vendors. So when the dialect you're using supports both the standard and the non-standard way, you should aim at using the standard form of coding. You should consider only using this non-standard form when it contains some important features that you cannot get in the standard form of the SQL. So over here, I indicated on the screen that it is best practice to write a standard way, because your code will be more portable. You can run your code in different environments, and your knowledge too will be more portable. So I mentioned that when you're writing the code and the dialect you're using supports both the standard and the non-standard, you should aim at using the standard way of writing. To explain this further, T-SQL supports two not equal operators. If you want to express something not equal to something, in T-SQL, you can express it in two ways. The first one is this symbol here, the two angle brackets facing each other. And this is standard. You can use this symbol or this operator in the standard language. T-SQL also supports this one here. The exclamation mark and then the equal to sign also stand for not equal. So these two operators, you can use these two operators in your code. But one is standard and the other is not standard. And T-SQL supports both of them. So when you're writing your code, you should aim at using the one that is supported by the standard SQL. As I mentioned before, sometimes you don't have a choice but to use the non-standard version. For example, if you look at this code here, SQL has a number of functions to convert data from one type to another. The convert and the cast. The convert function and the cast function. The cast function is a standard. It is supported by the standard. But the convert function is not. However, the convert function, which is not a standard, also supports another argument that allows you to provide a style. As you convert your data, you can change the style or the format of the data. The convert function, which is not a standard, allows you to do this manipulation of your data, this extra manipulation of your data. But the cast doesn't. So when you are faced with using these two functions, if you need to use the style argument, then you don't have any choice but to go for the convert function, even though it is not a standard function. As we mentioned earlier, if we can go back to our diagram, we said that the standard SQL is based on the relational model. And this model is a mathematical model for data management and manipulation. A very common misconception is that when people hear of the term relation, they immediately talk of or think about relationships, something to do with foreign keys. But what SQL attempts to call tables is what is termed relation in the relational model. In the relational model, there is a term called relation, and that is what SQL attempts to call tables. But it doesn't do a very good job at that. It is important to notice that SQL deviates from the relational model. But as long as you understand the basic principles of the model, you can use SQL more effectively. So in this diagram here, as you see, we have the term relation in the relational model, but SQL calls it tables, even though it is not completely correct. The two terms are not synonymous. This is an example of a relation. As you can see at the bottom here, we have a relation of students and a relation of courses. You can transform this into tables, but strictly speaking, technically, the two are not synonymous. So what SQL attempts to call a table is what we refer to as relations in the model. A relation has a header and a body, and I'm trying to represent this in this form without actually making it look like a table. The header is made up of what SQL call columns or attributes. In the relational model, we will call them attributes, and in the SQL parlance, we call it columns. So an attribute has a name and a type. A relation, again, has a body, what SQL attempts to call rows. The body in the relation model that SQL calls rows is referred to as tuples. So at this point, let me mention that most of the fundamental aspects of learning SQL or understanding SQL comes from the terms sets and predicate logic. Remember that the headings of a relation is a set of attributes. The heading is a set of attributes, and the body of a relation is a set of tuples. So this brings us to the question, what is a set? So the question is, what is a set? Let's look at a definition given by one of the creators of the relational model. He says, by a set, we mean any collection M, that is a big M, into a whole of definite distinct objects, small m, which are called the elements of the set or the element of the big M, of our perception of or of our thought. From this definition, we come across some very important terms. For example, the first term we see in the definition is the word whole. So a set is an entity that is considered as a whole. We don't consider the individual elements in a set. If you understand this small concept, you'll be able to write a better T-SQL statements. Another term we come across in the definition is the word distinct, which means that a set cannot have duplicates. And this is a very fundamental aspect of coding in SQL. If you write any code that returns a result set that has duplicates, you have not created a relational data set. That data set you created, which contains the duplicates, is not relational. By the definition that we have just gone through, a set shouldn't have duplicates. All the elements in the set should be distinct. In other words, if you have a set AA, BC is the same as a set ABC. The multiplication of the one element doesn't change the definition of the set. So a set should not contain duplicates. And the other aspect of a set that is not clearly indicated in this definition, but it's implied, is that there is no order in a set. We shouldn't have an order in a set. If you have written a bit of SQL code, you see that sometimes you cannot use the order by clause. It doesn't allow you to use the order by clause in some circumstances, because a set shouldn't have order. So the set AB is the same as the set BA. The order is not important. Another branch of mathematics on which the relational model is based is known as the predicate logic. And the predicate is defined as an expression that, when attributed to an object, makes a proposition either true or false. Let's look at some example here. A predicate will say salary greater than 50,000. That's a predicate. And it becomes a proposition when we say John's salary is greater than 50,000. John's salary is greater than 50,000 is now a proposition in the light of the predicate that we just mentioned. The proposition will be either true or false if we apply the predicate to this proposition. If John's salary is 60,000, the proposition becomes true. Otherwise, it is false. Relational model uses predicates as one of its core elements. For example, you can enforce referential integrity by using predicates, and it's very common in T-SQL. You can also filter data by using predicates, where all the propositions that are true to the predicate or the filter will be selected in the record set. And you can even create a data model using this predicate logic. Let's look at this example here. This proposition says an order with order ID 10248 was placed on October 12, 2021 by customer with ID 7, and the order was handled by an employee with ID 3. This is a proposition. If we remove the numbers, and the dates, we are left with predicates. And remember that the heading of our relation is a set of attributes with name and type. So if we remove the numbers and the dates from this proposition here, we are left with attributes which have names and types. And these are the following attributes that we can extract from this proposition here. We can get order ID as an integer. Compare this order ID integer with the predicate that we saw earlier, that salary greater than 50,000. It compares to this order ID integer, and we also get another attribute from this proposition here, which is order date, and it's a date data type. So remember that our relation or the table, if you want to speak SQL language, is made up of header and body. And we mentioned that the header is made up of attributes with name and type, and the body is made up of tuples, or what we call rows. So continuing with this, we have customer ID or the cust ID, which we can also extract from the proposition here. And the last one is the employee ID, which is also a proposition here. So we've been able to extract these attributes from a proposition that we stated. And this is one of the fundamental aspects. The predicate logic is one of the fundamental aspects of T-SQL. So combining these two together, the sets properties and the predicate properties, you will know how to handle T-SQL codes. These are the foundations on which the language is built. So having come to this point, let us check our understanding of what we've just gone through. What are the mathematical branches that the relational model is based on? So we have mentioned two branches, and we will look at it. And the second one is, what is the difference between T-SQL and SQL? So for the first one, we said that T-SQL is based on the relational model, which in turn is based on two mathematical theories, set theory and predicate logic. And the second one is that SQL is a standard language that is controlled by some organization. And T-SQL and other relational database management systems are implementation of these standards. And T-SQL is the direct or an extension to SQL that Microsoft implements in its RDBMS, that is the SQL Server. In our last lesson, we looked at some aspects of T-SQL and how they are related to the standard SQL and then on the data model. As a T-SQL developer, you need to start thinking in a relational way because that is how the program is developed. However, in some way, Transact-SQL differ from the relational model in some aspects. But the program gives you enough tools so that if you understand the principle on which it is based, which is the data model, you should be able to write very solid and stable Transact-SQL. This all stems from the fact that if you start thinking in a relational way, you will be able to write better SQL codes. To refresh our memory from the last lesson, remember that a set or a relation has a header or a heading and a body. And we said that the heading is made up of the attributes, which have names and types. And these headings are what SQL tries to call columns. And it also has a body. A relation has a body, which in SQL terms we call rows. But in relational model terms, we call it tuples. Remember also that in our definition of a set is supposed to be considered as a whole. When you are looking at a set, you look at the whole set, the whole entity, the set as an entity, and not the individual elements in the set. This translates to the fact that you are supposed to write queries that interact with the table as a whole. You should avoid thinking in procedural terms and using cases and loops. These violate the principles of sets. And in writing your code in T-SQL, you actually perform relational operations and you should return a relational result. So these are some of the fundamentals that we need to make sure that we understand before we can write solid SQL statements. First, note that SQL has foundations on sets. And by definition, a set is always considered as a whole. So when you write your queries against a table, make sure that you try to address the table as a whole and not try to think in procedural terms. For people with procedural language coding. The natural way to think about interacting with data, be it a record set or a file or data reader, is through iterations, that is looping, and interacting with the data row by row. So for them, using cursors and other iterative process is an extension of what they know already. But the natural way to interact with T-SQL is to interact with the table as a whole. This translates to writing T-SQL queries. So always try to perform relational operations and try to return a relational result. Remember also that a set has no duplicates, as we saw before. A set shouldn't have duplicates. But T-SQL doesn't always enforce this rule. For example, you can create a table without a key, and you need to enforce the rule by creating keys or unique constraints. Even when the table doesn't allow duplicate rows, a query against that table can still produce duplications. And we will discuss this concept further in our course. For example, let's create this query here. Let's do select country. Let's do select country from HR employees. From HR employees, and let's run this code. Let me change over to my database, and let's execute this code. Select country from. Let's execute the code. You realize that you have duplicates here. USA appears 4 times, and UK appear a number of times. In this operation, we try to perform a relational operation on a relation, and we're supposed to return a relation. But as you can see, we return a set that contains duplicates. So this is, strictly speaking, we didn't return a relation. SQL didn't make any attempt to remove the duplicates at all for us. So in this case, SQL actually operates as a multiset. A multiset, also known as a bag or superset, can return duplicate values. So as we mentioned before, T-SQL sometimes violates from the relational model, as we have seen an example here. But we also mentioned that it gives you enough tools if you want to operate within the relational model rules. In this case here, we have another tool that will allow us to bring out a relation output. In other words, we can modify this code, this query, so that the result set will be relational. For example, we have a distinct operator that will allow us to have a result that is purely relational. So if I execute this code now, you realize that we have produced a relational result by removing all the duplicates in our result. Another aspect of our relational theory is that, or a set theory is that, a set has no particular order. The order of a set is not relevant. For this reason, you don't have to expect that when you write a code, the results will be in a particular order. Even if the table is indexed. That is conceptually, that you don't expect the result that you receive from a relation to be in a particular order. If you want the result to appear in a particular order, then you have to state that. You have to use some other aspect of SQL Server or the T-SQL to specify that. For example, let us run this code and see the results. Select employee ID. Let's select the employee ID, emp ID, and last name from this same table. So the results, as you see, appears that it has been sorted on last name in ascending order. But if the results were even presented in a different order, it will still be considered correct. So SQL Server, knowing that it doesn't need to present the results in any order at all, can choose any physical access method. For example, SQL Server could parallelize the query or scan the data in a file order as opposed to indexed order. So in this case, if you want to make sure that the result set is presented in a certain order, then you have to include the order by clause. Order by ID. This forces the result set to be presented in a certain order, as you can see from the output. As you can see from the output, this result set have now been ordered in a particular order based on the employee ID. So in this case, the result we have provided here is not relational, because we have already mentioned that a set, or in the relational model, a set doesn't have an order. So if the result that you produce from your query is ordered in a particular way, then it is no longer relational. This is what the standard calls a cursor. The result that we have produced here is a cursor, but it violates the principles of the relational model. The headings of a relation is defined by a set of attributes which are identified by names and type. And there is no order to these attributes. Conversely, SQL or T-SQL keep track of the ordinal positions of these columns as per the definition in the table. In other words, if you define your table and you name them, say, first name, second name, country, and the rest, SQL keep track of the order of these tables, of the order of these names in the table. And when you query with a select, you are guaranteed to get an order based on the column definition in the table. And also, SQL allows you to refer to the column positions of the columns in an order by clause. So for example, if we go back to SQL, instead of ordering by a column name, we can actually order by the position of that column in the table as we defined it. So let me create this result. As you can see, when we replace the employee ID with the number 1, we got the same results as when we ran with the employee ID. This is because the employee ID is it's in the column 1, is the ordinal position 1. So we can either use employee ID or the number 1 to refer to the employee ID in our order by clause. But beyond the fact that this practice is not relational, it doesn't produce relational value, because we need to, in the relation principle, we need to provide names for the columns. And beyond the fact that this practice of using ordinal positions in the order by is not relational, think about the possibility of future modification to the table. So for example, if we modify the number of columns in the table, and the database creator forgets to actually modify the query that uses the ordinal position, you're going to get completely different results. For example, if in future we, instead of employee ID, we have another column as the first column, and we forget to change the query and make the order by to become the second column, because now we've pushed the employee ID to become second column, to become the second column. If we don't modify the query accordingly, we're going to get different results. So apart from the fact that this using the ordinary position in our queries like we have done is not relational, it also provides a means of creating wrong result set based on the fact that any changes we make to the base table may also rearrange the positions of these ordinal positions of these columns. T-SQL also had another deviation from the relational model in that it allows us to create an expression for a column without actually providing name for the expression. For example, if we modify this column here, this table here, this query here, and say last name or first name, I think it's first name. If we have first name plus and a space and the last name, we can run this query quite all right, and SQL will not complain, even though we haven't provided an alias for the expression here. We haven't provided an alias. Let me run this code here. Let me execute it. You realize that we don't have a column name for the second column. That is the full name. We don't have a column name. And this is a violation of the standard model. Because according to the standard model, according to the relational model, all attributes must have names and type. But as you can see, this attribute here, the column, the second column, doesn't have a name. To make the result set relational, we have to provide a name for the emp ID. We have to provide a name for the expression. So, for example, we could give it an alias and call it full name. And when we run the code again, we now provide a name for the expression. That is that column. And so this is fully relational. The result set is now fully relational. And again, T-SQL allows you to create a result set with the same names for columns, which violates the relational model. For example, let us select some artificial values here. Let's say we select AAA as AAA. And we select BBB as AAA. If we run this code here, I'd rather put the code in the wrong place. So we select AAA, which is a literal value, and we call the column AAA. And then we select a literal value called BBB, and we call it AAA. If we run this code here, you realize that the columns, both columns have the heading AAA, and this violates the relational model, because in the relational model, there should be unique names for each attribute. So for this result set to be relational, we have to give different names to the attributes. So we can call this one here, say BBB. And now it becomes relational now, because we have two different header names for the attributes. As for predicates, if we follow the law of excluded middle in mathematical logic, a predicate should have two values, either true or false. This follows the law of excluded middle in mathematics. But the creators of the relational model thought it wise to include a third unknown, a third element in the predicate that is unknown. So in T-SQL, you can have a true value, a false value, or an unknown value. In fact, unknown is not a value. It is the presence of or the absence of data. Unknown is an absence of data. It is not, or an absence of value. It is, strictly speaking, not called unknown value. There is no value that is called unknown. So we have true values, false. We have true, false, and unknown. And unknown can be represented in T-SQL. We represent this unknown mark by null. So what we should consider when it comes to null in T-SQL is that their treatment is not trivial. We have to be careful how we represent unknown values in our tables, because they can affect the resulting query, the result that you get from your query when you use nulls. There are so many instances where nulls are considered, and in some other situations, nulls are not considered in your result set. So the presence of nulls can make your queries, or should make you think hard when you are writing your queries. So let's end here with some quick check of our lesson. Can you name two aspects in which T-SQL deviates from the relational model? And let's go on and say, explain how you can address the two items in this question here, the question at the top here, and use T-SQL in a relational way. So first, name two aspects in which T-SQL deviates from the relational model. And we've looked at a couple, the naming of attributes, the absence of names in attributes, where we can write an expression and not provide an alias that violates the relational model. The presence of duplicates violates the relational model, and a few other considerations. And explain how you can address the two items in question one and use T-SQL in a relational way. And we've looked at some examples where we provide alias for our expressions for a column, where we provide distinct so that we don't have duplicates in our result set. So a relation has a body with a distinct set of tuples. A table doesn't have to have a key. So if the table doesn't, you don't have to provide a key for your table. That one is a violation of the data model, of the relational model. And T-SQL allow referring to ordinal positions of columns in the order by clause. So you can say order by 1, then 2, and so on and so forth. And that also violates the relational model. So to solve this problem that we have used here, this example that we have used here, first you define a key in every table. So because if you don't define a key, you can duplicate columns. But with the presence of a key, a primary key, it is impossible for you to provide duplication for the rows. And second one is refer to attributes names. So when you are ordering by, don't use ordinal positions. Use attribute names like employee ID in your order by clause. Let's look at this question 2. Answer the following question to test your knowledge of the information in this lesson. You can click next to review the answer. Number one, why is it important to use standard SQL code whenever possible and know what is standard and what isn't? Why is it important to know that? Why is it important to use in every situation when possible to use the standard code? And we've provided answers here. It is not important to code using standard SQL. Standard SQL code is more important between platforms. And standard code is more efficient. Knowing what standard code is makes your knowledge more portable. So if we look at the answer, we can provide the answer. The first one is incorrect. It is important to use standard code. The second one is correct. Standard SQL code is more portable. So when you write in the standard code, wherever possible, you can use your code in different situations. And the third one is incorrect. It says standard code is more efficient. No, there is no assurance that standard code will be more efficient. And the question D is correct. When using standard code, you can adapt to a new environment more easily because standard code elements look similar in different platforms. Which of the following is not a violation of the relational model? The first one is using ordinal positions for columns. Is it a violation or not? Returning duplicate rows. Is it a violation or not? Not defining a key in a table. Is it a violation or not? Ensuring all attributes in the results of a query have names. So obviously, our correct answer is D. All the other three, or the first three, violate the standard, the relational model, except the last one. And this third and last question: what is the relationship between SQL and T-SQL? And the first is T-SQL is standard language, and SQL is the dialect. It's rather the opposite way, the other way around. SQL is the standard language, and T-SQL is the dialect. That is correct. Both SQL and T-SQL are standard languages. That is not true. Both SQL and T-SQL are dialects in Microsoft SQL Server. That's not true. So it is SQL is the standard language, and Transact-SQL is the dialect of the standard. So as you can see, the answer B is correct. SQL is standard, and T-SQL is a dialect. So that brings us to the end of this section. This brings us to the end of this lesson. Transact-SQL has both the physical and the logical side. The logical side is the conceptual interpretation of the query and what the correct result is. The physical side is the processing of the query by the database engine. And in doing so, the database engine might decide to optimize the query. Optimization means that the database engine might decide to ignore some of the steps presented by the logical query. In other words, it might reorder the logical steps of the query, or it can even completely remove some of the steps, so long as the final result is achieved as required by the logical presentation. So in this lesson here, we're going to concentrate on the logical side of our query. As already mentioned, the logical side is the actual interpretation, the conceptual interpretation of the query, how you actually enter your code. That is the key in, the way you keyed in the code is the logical side. But when you present the code to the database engine, it might decide to follow different steps than the logical steps. And this is the physical side of the query. And in doing so, the database engine might decide to reorder the steps that you have given to it, or it might even remove completely some of the steps just to optimize the query Our focus now at this time is the logical processing of the query. And after this lesson, you should be able to achieve the following. You should understand the reason for the design of T-SQL, and you should be able to describe the main logical query processing phases, how you keyed in your query. You should be able to describe every phase of it, and explain the reason for some of the restrictions in T-SQL queries. Transact-SQL actually is a declarative language. It's like English language. So in this language, the declarative means that you define what you want. What you want is what you are concerned with, the declarative side of the language, as opposed to imperative. Imperative concerned with how to achieve what you want. So the declarative side of the language deals with what you want to achieve, the results you want. And the imperative side of the language deals with how to achieve the results that you want. So the standard SQL actually describes the declarative part of the query, what you want to achieve. And a database engine is also concerned with how to give you the results that you want. For this reason, it is important that you don't draw any performance-related conclusion to what you learn about the logical processing. You shouldn't attach any performance-related interpretation to the logical processing of your queries. So this is because the logical side of the query just is only concerned with giving you what you want. And the database engine is concerned with the optimization, how to optimize the query so that it will give you exactly what you want without spending too much resources. That is the job of the database engine. So as we have said before, optimization is completely different from the logical processing, and it is allowed to change things as long as the result that you are looking for is achieved for you. Actually, it is interesting to know that the original language was not called SQL. It was called SQL, that is Structured English Query Language. That was the name of the original language, SEQUEL, that is SQL, which stands for Structured English Query Language. It was due to some legal tussles between Microsoft and some airline company that the name of the language was changed from SQL to SQL, Structured Query Language. So let us move on. As we have said, the declarative part of the language is to do with what you are looking for. And the database engine is concerned with how to get for you what you are looking for. Let's look at the declarative language here. You can give this statement to a person: bring me a soda from the refrigerator. Bring me a soda from the refrigerator. And observe that in this instruction, it is purely English. And the object comes first before the location. The object that you want is mentioned first before the location. Consider the following query. Select shipper ID, phone, and company name from sales shippers. Over here, observe the similarity of the query to the way the English is structured. You first use the select first. So you mention the object that you want first. This is the thing that you want. And before you even mention the location where you want the object from. In this way, you mention the select first before the from. So now try to think of how you will give this command to a robot. When you are talking to a robot, you have to be precise. You say something along the lines of this. Go to the refrigerator, open the door, get a soda, bring it to me. So computer, having a behavior like a robot, will want to know first where you want it to go to get you what you want. So actually the logical processing of the query will want to know what table to go to first before it can even retrieve you the properties or the attributes of the query. As you can see from this one here, this code here, we have keyed in the top code, select something from this table. But in processing the query, the logical processing will first want to know where to fetch what you want it to fetch. So in this case, the location comes first, even before the object that you want to be fetched. So this is just an example of only 2 clauses. Things can get more complex than this. But if you understand the processing of the logical query, the logical processing phase, you can eliminate some of the difficulties that you may face in your SQL scripting or querying. Some of the behaviors of SQL are quite difficult to understand and explain if you don't really get the fundamentals of how the queries are processed. Now let us look at the logical query processing phases. Don't stress too much if you don't fully understand this topic at the first go. I have treated them into more details in my other modules 2, 3, 4, and 5, which you can also purchase and reinforce your understanding of this topic. The clause that you use to select data from your database is the select statement. And following are the main phases of the select statement, how you retrieve data from your database, from your queries, using your queries. First is the select statement, the clause, followed by the from clause. This is how you key in your query. If you're writing a query to select data, this is how you key it in. You start with the select and then the from, followed by the where clause, then the group by, and then you have the having. If you have to use the having, this one follows the group by clause, and finally you order by using the order by clause. So in fact, this is how you will enter your query to select some data for you. But as you have mentioned earlier, the logical processing phases are different from this. That one starts with the from clause. You have to tell it where to go to fetch what you want. So it starts from the from clause. Then before it goes to the location, so you use the from where before you filter, actually, before you select what you want, and then followed by the group by having. This is the point where it actually do the selection. This is where the select clause comes in after the having clause, and then you order your query, and then you apply the order by clause to the query. In processing the queries, each phase has one or more tables as an input. Each phase is fed with tables as an input and returns a virtual table. So this return table is also used as an input to the next phase. Notice that if you use the order by, the result set is not relational. So the fact that each phase is fed with the tables from the previous phase is in line with relational operation. Relational operations work on relations to produce relations. So as I've mentioned, the order by, if used, will produce a result set that is not relational. This statement that I've just made, namely the fact that the order by clause doesn't produce a relational operation, has some implications which I discuss into details in my other module, filtering and sorting data. Let us look at the phases of this logical processing. First, let us copy this code here. Let me copy it and paste it in our query editor. So I'll copy it and I will open my SQL Server and paste it here. Let us run it. Let us run the query. And we get 2 records from UK. So going back to our interface here, we're trying to select these attributes from the employees table and we are filtering for only employees who were hired on this date, that is 1st January 2003. And when we've got the result, we want to group them, we want to place them into groups of countries. So we want to group the employees into countries. And within the country, we want to group for the year of the date that was the person was hired. And after we've grouped, we will discard, we will throw away all the groups that have only one employee. So we will select only employees, only groups that have more than one employee, and then we order the results by country and then the hire date. Let's go through the phases. First is the from clause. So the first phase, as far as the logical query processing is concerned, is the from clause. And the output of the from clause is all the rows from the table, from the specified table. And this table can come from just one table, or you can get information from different tables or more than one tables by using a join or even a subquery. So the from clause is involved with the tables that are participating in the query. So if we go back, in fact, if we go back to our database engine here, if we remove this, the result we get here is the output to the next phase. Of course, I cannot get the results here because we have an aggregate function here. So I may have to jump and then group the result. Group by, because we have an aggregate function here, we have to group by those that we are not aggregating. So I will copy it. But we will discuss it at this point as we go and execute. So let me execute again. That's what you get when you copy and paste. So let me execute now. So this is the first phase. That is the from clause. And the result set is fed, is the input to the next phase. So our next phase from after the from clause is the filter. That is the filter phase, where we use the where clause. So let us go back into our query editor and supply this filter here. So in this case, we have now, before I go ahead, let's go back here and let me point out something. Over here, I stated filter rows based on the where clause. I said based on the where clause because there are other means of filtering that is not based on the where clause, like the having. The having clause also filters rows, but we haven't come to that point yet. So at least we have two ways here to filter. That is the where and then the having clause. So that's why I qualify this one here with filter rows based on the where clause. So if we go back to our query now, let's add the where hire date. Where hire date is equal to or greater than 2003 0101. So now we've supplied the where clause with our output from the from clause. The from clause provided us an output, which we have supplied to the where clause. So the where clause is going to use the output from the from clause and then do more processing to get the filter, to filter out what we don't need. And then the results will be another relational data. The results we get from the where clause will also be a relational data. So we are supplying the where clause with the relational data that we receive from the from clause. So if we execute this one here, we have filtered out only for employees who were hired on or after this date. Notice that The filter is for employees who were hired on or after the year 2003. Because 1st January 2003 means that the year is for all employees who were hired on or after this year, after the year 2003. One mistake that novices of SQL Server make is that because we have calculated year hired here, this one here, we have calculated the year of the hired date. We've extracted the year of the hired date and we have called it year hired. So they think when they get here, they can say where year hired equals to 2003. They want to get here year hired. If they want to get the year when the employee was hired, because they have already calculated the year hired here using the function year hired date, this function has extracted the year part of the date. So people think that when they get here to filter, they can use what they have calculated here to filter. But as you realize, SQL Server has, if we put our cursor there, it says invalid column name, year hired. But we have actually specified that this one here, this function here, this expression here is called year hired. But yet still, SQL Server doesn't see it. The engine doesn't see it. This is because if we go back to our query when we were doing the processing, we said that the from clause happens before the where. But at this time here, you see the where clause is ahead of the select. The where clause is processed first before the select. So when you are processing the select, the where clause, you cannot refer to anything that you specify in the select. By the time the where clause is being processed, we haven't processed any select statements yet. So when you refer to anything in the select statement, over here you can see it. The where clause doesn't see anything. So if we go back here to where we were before, if we go back here, when you say hired date equals to 2003, the year hired equals to 2003. The year hired is calculated in the select, but at this time here, the from clause, when it is being processed, this statement has not been executed yet. So this one doesn't exist. So if we run this code here, if we execute this code here, as you can see, we are having problems. It says invalid column name, year hired. So you might think that because you have selected this expression here and called it year hired, you can filter it using that expression. But if you remember that the where clause, when it is being processed, the select clause has not been processed yet. So this expression here doesn't exist. So the best way to express this here for the filter is to write the whole expression again. So it is, you can do, say, year hired equals to year hired date. So you are writing the expression again. Actually, this should be where year hired equals to 2003. 2003. So in this case, you are actually writing the expression again, the expression to extract the year. So you extract the year part and you compare it with 2000. So if the year part is 2000, it is included in the result set. Remember that in this where part, nulls, fields that have nulls, that is unknown, and fields that are filtered out are not included in the query results set. So we can run this code here. So we can run this code here to obtain our result. So this query is syntactically valid, but for optimization purposes, instead of doing this, you can actually say where higher date. You can say where higher date. Where higher date. Because higher date is a column in the database. So we are filtering on the higher date, and it's greater than the actual date, the full date. That is 2003 0101. So anything on or after 2003, that is 1st January 2003, anything after 1st January 2003 is the same as stating that it is the greater than or equal to the year 2003. This is for optimization purposes. The last one we wrote, that is where year higher date is equal to or greater than 2003. You can write it as this one too, but this one is more optimized. This line here is more optimized, and we discussed that in some of our modules. The group by phase is the third phase in our logical processing, and it is the phase that produces groups for each distinct combination of values per group from the table. When we group by, we separate we put the values into groups based on the distinct combination of the values that we are grouping by. Let us go into our query editor and look at this code here. Let me separate these ones. We are up to here, the where clause. When we select the up to the where clause, we have received, say, 6 rows. USA for 2003, UK for 2003, UK for 2003, UK for 2004, UK for 2004, and USA for 2004. So we haven't grouped these data yet. They are individual rows that have been retained. And remember that because we are filtering based on this condition here, every the year hired is either 2003 or greater. We have filtered out anything that is less than 2003. So we don't have 2002, 2001, and 2000, and so on and so forth. We filtered for only anything that is greater than 2000, that is greater than or equals to 2003. And remember that this filter here is based on rows. We are filtering rows. So each row where the higher date is less than this date here is taken out of the final result. Now that is where the where clause comes in, ends. Now we want to group the data, where this is the phase that we are discussing now. If I remove this one here, the count, if I remove the count, and we want to select the count, if I run it here, sorry, I should have selected the data. If I select the data and run it here, I want to separate it from the group by. So if I run this data here without the group by, we're going to receive an error. And the error says that we don't have this, the country, and this one here, the year by, in the group. Because if I comment this one out, and I run the query again without the group by, you realize that This is the result we had before I removed the comment. So if we want to add the count, if we want to add this one here, if we want to select the count, what count? What are we counting? Are we counting for the whole query, the whole result set? Because count will give us a single value. Remember that if you count something, you get a single value. But what is that value for? Is it for the whole record set, the number of records in the returned, or it is the count of USA for 2003, or is it the count for UK 2003, or is it the count for UK 2004? What exactly are we counting? It becomes difficult. You cannot tell, because if you count alone, you get a single value, and what is that single value going to be attached to? So to solve that problem, you have to count for each group. If what you need to break the results into groups, and then if you then use the count, it will count for each group. At the moment, we are not grouping. So if we select this one here, we have an error, because the count value, the single value for the count, doesn't know what are you counting for? What exactly are you counting for? So if I comment it again, let me comment it again, and then run it again, we get these values here, like we saw before. And if we want to add the count, because over here now we have removed the count, so we are not counting anything. But if we want to count it, we have to be specific what we are counting for. At the moment, if we count, we don't know what the count stands for. It can't stand for the whole records, and it can't. You are not specifying what the count is for. So to remove to count, then you have to count per this group, per the group that you have specified, the columns that you have specified for each group. So in that case, we have to group, because we have an aggregate function here. We have to group so that the aggregate function, the results of the aggregate function, will be for each group. So now, if I have removed the comment, so we are going to count and we are going to group. So if I now run the query, you realize that the count is for each group. Now, the query engine knows what you need the count for. You want to count for each group. So for UK and 2003, we have two groups. USA and 2003, we have one group. The count is just one group. We have UK 2004 for two groups, and USA 2004 for one group. Again, if I remove the count, let me remove the count again and go back to where we were. Execute. You realize that for UK 2003, we have two groups, as we just saw. UK for 2003, we have two groups. UK for 2004, we have two groups, this one here and this one here. So if we are counting per the group, this is what we get. This is what we get here. We group and then we count for each group. And this is exactly what we got. For UK for 2003, we have two of them. UK for 2004, you have two of them. So the take home here is that if you group and you use an aggregate function like sum, average, minimum, those functions provide just one value. That's why we call it aggregate. It aggregates the data and produces one value. So you just can't count it without grouping. You have to count, you have to group when you count, so that the counting will be per group. The group, and the group, you group by the ordinary non-aggregate columns. So over here, country, we didn't count the country. It is ordinary. It is bare. It is a naked country. And then over here, we selected the year. And so we have to group by these two that do not have any aggregate. We have to group by the two that do not have any aggregate. That is why we have grouped by UK, country and year, country and year. So that is the purpose of the group by, this phase. It produces unique combination of values per group. So if we go back to our query here, that is the group by. So that is the result that we just saw from the query editor. For UK, we have 2003, we have 2 for employee ID 5 and 6. And for 2004, which is another group, because UK 2004 is different from UK 2003. So the 2004 one for UK also have 2 count, that is 7 and 9 employee ID. And the rest, USA has 1 for 2003 and 1 for 2004. That is employee ID 8, and the other one is employee ID 4, and the other one is employee ID 8. So that is the purpose of the grouping. When you group, remember that in the select phase, when you group, you have to make sure that the group contains all the attributes that you are not aggregating. The group by contains all the attributes that you are not aggregating. So over here, the group by contains the country and year that we are not aggregating. And this one here produces one value, just one single value. And that is why we have to group, so that the count will be attached to each group. We count for each group. Now let's go to the having clause here. The next one is this having clause here. And as I've stated here, the having clause is just like the where clause. It filters data. So there are 2 ways to filter your data, either the where clause or the having clause. And you can use them in the same, you can use both in the same query, as we are going to see. So this is evaluated per group and filters group as a whole. So the where clause filters rows. It filters every row. It removes all the rows from the base table before you can group it. And because the grouping has already been done, the where clause comes after the having clause, the having clause comes after the where clause, comes after the grouping clause, the having clause comes after the grouping. So when you group, any processing that comes after, the phase that comes after, must produce values for the group, because you've already produced a grouped results. So you are passing this grouped results to the having clause. So the having clause, whatever it produces, must work on the groups. It cannot work on individual rows now, because the data has already been grouped, and you have passed the grouped results to the having clause. So the having clause must filter per row. The having clause works on the group that it has received, not on individual rows. So it is equivalent to per group and filters group as a whole. So the having clause will filter the group as a whole. In this case, the having clause uses the count. So if we go back to our SQL Server here, after we grouped and got this data below here, we apply the having clause. We apply the having clause. And the having clause, in the having clause, we filter for only the count value that is greater than 1. So we say having, after you've grouped, pick all the rows that have the count greater than 1. And you see that UK 2003 and UK 2004 are the only groups that have a count greater than 1. So the having clause is working on the count, on the groups. It doesn't work on individual rows, it works on the group. And it works after you have grouped the data. So if we run this one here, where is my F5? You realize that the having clause has now taken place. The having clause has produced this result here. It has filtered out all the rows that have, all the groups that had a count of 1. It has given us only the rows that have a count greater than 1. So that is how the having clause is. So if we go back to our interface, this is what we are doing here. We first filtered for rows that are greater than or equal to this, and then we grouped. And when we grouped, we got 4 rows or 4 groups, and then we used the having to remove the groups that were less than 1, and we presented only the groups that were greater than 1, and then we ordered. So let's have a quick check here. What is the difference between the where and the having clauses? And this is quite simple. The where clause is evaluated before rows are grouped. So the where clause acts on the individual rows in the table, and therefore it's evaluated per row. The having clause is evaluated after rows are grouped, and therefore it's evaluated per group. So the having clause, after you have grouped your data, then you use the having clause to remove some of the groups that don't satisfy the filter. Now we jump onto the 5th phase, that is the select phase. And it's interesting that this phase is almost towards the end of the processing, considering the fact that it is keyed in first. When you create your query, you actually key in the select statement first, but in the processing phase, it is almost the last but one. And if we look at our query again, you realize that the query, the select, is actually it provides aliases for expressions like the count and then the year hired. This select phase provides expressions or aliases for them. And this process here, this phase here, has 2 steps. As I've already mentioned, it evaluates expressions in the select list and produces the resulting attribute. So the select phase is processed, and the attribute that we have defined for it are produced as the result set. So if we go back to our query that we ran before, this is the results of the select phase. And at this phase, the query, the result is still relational. This is a relational result that we have received here. And at this point, remember that all the phases that come before the select do not see anything that we have specified in the select statement. All the expressions that we have specified in the select statement, apart from attributes that are actually in the database, like country, you cannot reference any of the expressions in the select statement in any of the phases that come before the select statement. I think we have mentioned this a couple of times. I keep on repeating it because it is very important. So over here, we get 2 rows or two separate columns, because we use the having clause to filter out the columns that don't meet the filter condition. The next phase, or the next step of the select phase, is the application of the distinct clause to remove duplicates. Remember that T-SQL is multi-relational. In other words, if it allows you to receive duplicate values in your result set. So it is up to you to remove duplicates if you don't need them in the result set. And the way you do that is to use the distinct clause to remove duplicates. So the select statement has two steps. The first one is to select the actual attributes that we specify to it. And the next thing it does is to use the distinct clause, if you have supplied it, to remove all duplicates within the result set. If you don't remove duplicates and duplicates are retained, the result set is not relational, because as we mentioned from the beginning of this lesson, relational data don't have duplicates. A set don't have duplicates. A set of A, B is the same as a set of AB. So it is up to you to remove the duplicates. If you want to make your result set relational, it's up to you to remove the duplicates by using the distinct keyword. So as we've already mentioned, the result from this phase here, the select phase, is relational. And relational also means that the order of the result set is not guaranteed. That is one of the properties of a relational, of the relation. That is, order is not guaranteed. So if you have a set which is a relational, AB, a set of AB is the same as a set of BA, the order of the elements is not very important. So if you want to ensure that the result is presented in a certain order, then you have to use the order by clause. And in that case, the result set is not relational after you've used the order by clause. So let us quickly have a refresher. Why are you not allowed to refer to a column alias defined by the select clause in the where clause? Why can't you, if you supply an alias in the select clause, why can't you use that alias in the where clause? Number two, why are you not allowed to refer to a column alias defined by the select clause in the same select clause? So I don't think we've talked about the second part, but in the select clause, if we go back here, if we go back to our query here, in the select clause, let me remove this. I can say select. Let me remove this one here. Let me remove this one here. Let me comment it out, and then we select this one here. So we've selected this one here. Notice that we have an expression as year of the higher date, that is 2002, 2003, 2004, and so on and so forth. We have an expression there. Let's say we want to also select the previous year. Can we say year hired -1? Can we say that? Let me put a comma here. As you can see, SQL, the engine has already indicated that this reference here is wrong. It says invalid column name, year hired. But we've already calculated the year hired here. So why can't we just use it and say year hired minus 1, so that if it is 2002, this one will become 2001. If it is 2003, if the year hired is 2003, then this one becomes 2002. Why can't we do that? What is happening here is that even in the same select statement, you cannot reference an expression. It doesn't see it. This is what we call all at once concept. The all at once concept doesn't allow you to see this one here, even within the same select statement, because it is being processed at the same time. This year hired minus 1 is being processed at the same time as this. Conceptually, it is being processed at the same time as this. It is not that this one is processed first and then it processes this one. If it is processed first, then surely this is not going to be an error. It will see it because this one has already been processed. But in SQL Server, one of the concepts that I discuss in my other some of my other units or modules is that everything, when we do a select or update or action queries like that, everything happens at the same time. They don't happen in sequence. So the highest date, as it is being processed at the same time as the year hired. So you can't reference this one here in any other place, even in the same select phase. So that is the concept of the all at once of any phase. It happens at the same time, so it is not seen. So having explained this briefly, let's go back to our. So why are you not allowed to refer to a column alias defined by the select clause in the same select state clause? Because of the concept of all at once in the select phase. The select is happening at the same time. It is not that you are selecting one expression and then you can use that for the next expression to the right. No, you can't. They happen at the same time. So the first one is that because the where clause is logically evaluated in the phase earlier to the one that evaluates the select clause. So when the where clause is being evaluated, we haven't done anything to the select clause yet. So anything in the select clause cannot be referenced anywhere because it hasn't happened yet. The second one is because all expressions that appear in the same logical query processing phase are evaluated conceptually at the same point in time. That, as I have underlined, the same point in time. They happen at the same time, so you cannot reference any of them. They are all coming at the same time. So one is not older than the other. So you cannot say, I have calculated A, so I'm using A somewhere else in the same phase. No, it doesn't happen. And this is known as the all at once concept. And I said, please see my other course on insert, update, and delete for more on this. So the next and last phase we look at is the order by, and it is used to handle presentation. If you want to present the data in a certain order, then you can use the order by clause. And what it produces is not a relational result. The order by clause, if you use it, the result from the order by produces a data set that is not relational. That is what SQL calls a cursor. And you can do that when you want to present the results in a certain order just for presentation sake, but not for processing sake, not for any processing sake. Or when you want to present the data to some other program that uses the data in a cursor manner, that is, step through the records one at a time. So this is a cursor. If you use the order by, it is a cursor. It is not relational. And the order by also comes at a cost. It uses resources to order the data in that manner. So if you are not using it for presentation sake, you have to avoid using the order by in any of your queries. You can use the order by when you use the top or the offset, but that is strictly speaking after the select statement, after the select has retrieved the attributes and removed any duplicates. That is where you can use the top or the offset. But strictly speaking, it is best to avoid using the order by clause unless you are using it to present your data for reporting or for other actions like that. So this brings us to the end of our this lesson here. But before we go, let's quickly run through what we've just gone through, the understanding query process, logical query processing. We said that it has two sides. Query processing has two sides. That is the logical and the physical. The physical is the conceptual interpretation. The logical is the conceptual interpretation of the query. That explains what is being, what you want to produce. And the physical is to do with the database engine, how the database will actually process the logical query to present the data to you, what we want to you, in the most efficient way. And we said that in doing that, it may optimize the query. So it can remove some steps completely if it is not going to affect the result. Or it can rearrange the steps to produce the result that you require. And our lesson was actually focused on the logical processing side. And this is what we have gone through. Understand the reasoning for the design of T-SQL. Describe the main logical query processing phases. And we've gone through the 6 of the phases. And explain the reason some of the restrictions in T-SQL. It's just because what we think should be produced first is not actually producing by the engine. It is actually producing it later in the phases. And we said that T-SQL is both declarative and imperative. The declarative defines what you want, the result that you want. And the database engine works with how to give you the result. So that is where the optimization comes in, how. And we use some English expressions like stating the order, the object first before the location, as you can see in this example here. And then we restated it as if we are talking to a machine. You become specific. You want to tell it where to go to get the object that you require for you. And this is how we write it in our code, how it is actually expressed in our code. From this, select this one here. That is how the query will process it, even though we don't write it that way. And we looked at the logical processing phases. And it starts from the select, followed by the from, then the where, and then we group. And after grouping, we pass it on to the having. If we specify any having clause in the query, it passes it on to the having. So the having clause is dealing with a grouped data set. It's not dealing with individual rows, but grouped data set. So the filter for the having actually filters groups out or in, and then we order by. And that is the last phase of the query. And it is in this phase here, you can reference anything in the select clause. You can reference anything. Actually, this is how it is written. This is not the logical field, it is how it is written. But this is how it is processed. It starts with a from, where, group by, having, and select. So in all this, up to this time, up to here, because the select comes after, you cannot reference anything you have provided in the select. Any expression you provide in the select, you cannot reference them in any of these phases because the select hasn't happened yet. And then we go to the order by. In the order by, you can reference anything that you have done in the select, that you have expressed in the select. In the order by here, because it is the only one that comes after the select. You can reference an expression that you define in the select phase. And this is the query that we ran through, that we use for our example. So we started with the from clause, which is the first phase, and the output, it selects everything, all the records from the base table. The from clause uses all the records from the base table. And the table result with all rows from the input table. The output is the table from all the rows from the input table. And the output, this rows, is passed on to the where clause, where we do some filtering. For example, we filter for year greater than this. So the output from the from is given to the where clause, and then the filtering takes place. And we looked at the group by. After we have filtered, we may decide to group the results. So the third phase is the group by phase. And we looked at this example here where the grouping takes place. And then after the grouping, we pass the results on to the having clause. We have already grouped it. So the having clause is another filter phase, and it's going to filter for groups. So the having clause works on groups, the groups that is passed on to it from the group by phase. And this is what we said about the having clause. It is like the where clause, but it works on groups, not individual rows. And over here, we used a filter like count greater than 1, as we saw in the results. So we went through this. We have run this query here, and then we do some checks just to refresh our memory. And then the last phase, the last but one phase, the fifth phase, is the select clause. And we said that the select clause has two parts. It selects the expression that we have, the select list, to produce to select the attributes from the table that we have passed to it. And then the second part is that if we produce the result set with duplicates, SQL Server allows us to have duplicates, and the duplicates are not relational. So it is up to us to use the distinct keyword, and the select clause actually applies this distinct keyword to our data to make it relational, to remove duplicates. And we did another refresher of our memory, and then we went to the presentation phase where the data is ordered, and we said that it produces a non-relational result, which is called a cursor.